James Webb Telescope just discovered an insane new galaxy. Over the last 6 months, it has become abundantly evident that NASA's James Webb Space Telescope accomplishes precisely what it set out to do. The multi-billion-dollar machine is flawlessly unfolding the universe by disclosing cosmic light we cannot see with our own eyes, just as its developers had planned, and its amazing results make even the most unlikely stargazers feel alive. Twitter went crazy about a blurry red dot one day because of this gold-plated telescope. For 48 hours, people all across the world marvelled at the creation of a galaxy shortly after the advent of time itself. It appears that thanks to the JWST scientific prowess, humanity is united over stardust. But here's the catch: the James Webb Space Telescope has discovered an amazing new galaxy, and it could be one of the greatest discoveries of all time, proving that the cosmos is continuously expanding and that new things are still to come. The James Webb Telescope has only been studying the sky for a few weeks, but it has already revealed a surprising discovery. There are tens, hundreds and possibly thousands of times more luminous galaxies in the early cosmos than astronomers predicted. No one was expecting anything like this, says Michael Boylan-Colchin of the University of Texas, Austin. Galaxies are exploding out of the woodwork, says Rachel Somerville of the Flatiron Institute. Current galaxy formation models imply that gas clouds should consolidate into stars and galaxies much slower than Webb's galaxy-rich photos of the early cosmos, taken fewer than 500 million years after the Big Bang. This is way outside the box of what models were predicting, says Garth Illingworth of the University of California, UC Santa Cruz. Webb, a NASA-led orbiting observatory with participation from European and Canadian space agencies, began watching in late June from its 1.5 million kilometre vantage point. Much of its time has thus far been spent on studies designed to demonstrate its capabilities, such as the Cosmic Evolution Early Release Science (CEERS) survey. Webb is intended to probe deeper into cosmic history than the Hubble telescope. Its 6.5 meter mirror, which is 6 times the size of Hubble's, can capture more light from far sources, and unlike Hubble, it operates an infrared wavelength, making Webb more sensitive to those distant sources, whose light is stretched to longer, redder wavelengths by cosmic expansion. Within days of beginning observations, Webb discovered a candidate galaxy that appears to have shone brilliantly when the universe was only 230 million years old, 1.7% of its current age, making it the farthest remote yet seen. Since then, surveys have revealed the object is merely one of a dazzling swarm of early galaxies, each of which is modest by today's standards, but far more brilliant than scientists had ever predicted. Some researchers warn that the abundance may be an illusion based on photographs of small pieces of sky. Boylan-Colchin wonders if Webb just happened to look into a massive clump of galaxies that was denser than the rest of the early universe. That question will be answered when SEERS broadens its scope later this year and results from other large-scale surveys arrive. One of JWST's most lauded capabilities is its ability to see into the early universe and view some of the first galaxies and stars. Already, the telescope, which launched on Christmas Day 2021 and it's already 1.5 kilometers away from the Earth, has discovered the most distant and earliest known galaxies. When 2 teams independently reviewed JWST images for the GLASS survey, one of over 200 science programs planned for the telescope's first year in space, they discovered the galaxy. Both teams, led by Rohan Naidu of the Harvard-Smithsonian Center for Astrophysics in Massachusetts and Marco Castellano of the Astronomical Observatory of Rome, identified 2 particularly distant galaxies in the data. One so far away that JWST detects that light is emitted 400 million years after the Big Bang, trying the oldest galaxy ever seen by the Space Hubble telescope, and the other dubbed Glass Z13, seen as it appeared 300 million years after. It would be the most distant galaxy ever found, said Castellano. Both galaxies appear to be extremely small, approximately 100 times smaller than the Milky Way, but they exhibit astonishing rates of star formation and contain 1 billion times the mass of our Sun, more than predicted for galaxies this young. One of the young galaxies even has disk-like structure. More research will be conducted to dissect their light and discern their properties. Another early universe study, Cosmic Evolution, early release science, has discovered extremely distant galaxies. According to Rebecca Larson, an astronomer at the University of Texas at Austin and a member of the survey, only a few weeks into the study, the team has identified a number of galaxies from the universe's first 500 million years, though Larson and their colleagues have yet to publish their exact findings. It's better than I imagined, and it's only the beginning, she said. It's also possible that scientists are mistaking somewhat more modern galaxies for very early ones. Spectra are the gold standard for determining the age of galaxy because they correctly measure the reddening of its light. However, obtaining spectra from numerous galaxies takes time. Instead, Webb surveys have so far determined galaxy ages based on the colour they appear in images, an imprecise method. Webb's near-infrared sensor divides their light into a few broad wavelength bins, providing astronomers with a crude colour measurement: redder equals further away. However, dust encircling a galaxy can deceive viewers, because it absorbs starlight and re-emits it at a longer wavelength, making the galaxy appear redder. In just 6 months, we'll have a much better picture of all of this, Boylan Cochin says. It's a very exciting time. JWST should also be able to detect far more distant supernovas, giving it yet another ability to serve as a probe of the early cosmos. It may also discover stars being ripped apart by supermassive black holes at galaxies' centres, which no previous observatory has discovered. For the first time, we're going to be able to peer into these very deep dark regions, said Ori Fox, an astronomer at the Space Telescope Science Institute who leads the team studying transients. Transients, like other astronomical phenomena, are about to be redefined. JWST has launched into space after decades of planning and development. The problem now is keeping up with the steady assault of research flowing down from a system so complicated yet faultless that it almost defies belief that it was developed by human brains. It's working and it's insane, said Larson. So what are your feelings on the matter? Isn't this fantastic? We've entered a future full of fresh adventures and discoveries, and there's no stopping us now.